Picking up with section 1.4, we're going to revisit some old problems and then venture into some new ones. But the big common theme you can see with our learning target at the top of the screen, I can determine limits involving infinity. If I gave you f of x is 1 over x plus 3, of course we could envision a graph. We have, this is the graph of the Kung Fu fighter, and we're going to move that graph 3 steps to the left with X files. So, from a graphical perspective, we can pretty much see what is occurring right here. Of course, a graphing calculator could also be used to help out. But we can see as X would approach -3 from the right-hand side, we'd be heading up towards positive infinity. As we'd be approaching -3 from the left-hand side in part B, we'd be moving towards negative infinity. Because we have disagreement in the signs here, we can say just as we approach -3 in general, we would not exist. Now, of course, as we're approaching -3 from the right, really that's like having a number such as -2.9. I guess the thing I'm trying to point out is a numerical perspective. This is all review. If I plug in -2.9 into that function, my denominator, of course, would be positive and also small. And 1 over small is big, but it's a positive big. Similarly, we could investigate plugging in -3.1. And if we did, our denominator would be negative, of course, and it would be small. But 1 over small is big, but it's in a negative direction, so we're going towards negative infinity. Just wanted to point out the obvious that you could look at this problem graphically, like we originally did, or numerically. Take a look at number 2. So we're looking at number 2. We've got g of x is 1 over x plus 3, whole thing squared. Going back to the very start of the year, this would be the volcano graph. When you're seeing a quantity squared as a volcano shape to it, a graphing calculator would confirm. As we approach -3 from the left or from the right, and I believe this right here, forgive the typo, would be saying that we're approaching -3 from this other side, perhaps from the left side, changing some signs here. You can see that we'd be still headed towards positive infinity. You could just as well do a numerical approach, realizing that down below you're squaring in that denominator. So at the end of the day, you're guaranteed to have something positive in the denominator. If you have an odd power, very important to point out, odd powers have a Kung Fu fighter kind of a shape. This graph of 1 over x minus 2, we're going to move 2 steps to the right through X files. But it has much the same shape that we'd have from example 1. It's got that Kung Fu fighter shape. And then we can see as approaching from the left side, 2 from the left, we'd be headed towards negative infinity. From the right, we'd be going to positive infinity. And then in general, because we have disagreement in signs, we'd say D and E. As we look even at something like number 4, you might not feel as comfortable making a graph. That being said, we can investigate what would happen if we plugged in something like 2.1. Our top, of course, would be, positive. Down below, though, we'd have a positive as well. 2.1 minus 2 is something small, but in a positive direction. Just from that kind of an analysis, we could know that we're going to be arriving at positive infinity. As we look at number 5, we could very quickly get this graphed out on the calculator. And we could type in 2 minus 1 all over x. And we can change our setting on the table. Go to second table set, actually go to ask. And then if we had that freedom, we could plug in, say, 100. We could plug in 1,000 if we'd like. We could even plug in 100,000. And we could plug in whatever we'd like, but you can see, looks like we're at 1.99. Here's 1.999, it appears. Sometimes kids will look and say, well, look, you actually hit 2. But if we hit the right arrow over, we'd see that we have 5 nines. It's a hint that we might think that this limit as x approaches infinity of 2 minus 1 all over x using our calculator would be approaching 2. We're going to stop right here for the sake of time making the video. We'll pick up with it part 2.